Today we're diving into a topic that's been a subject of debate and fascination for years: Pluto, and why it's no longer considered a planet. It's a story full of discoveries, scientific debates, and a bit of nostalgia for many of us who grew up with Pluto as the ninth planet in our solar system. So, let's get into it and explore every aspect of this cosmic controversy. First off, let's talk about the discovery of Pluto. It was back in 1930 when Clyde Tombaugh, an American astronomer, discovered Pluto at the Lowell Observatory in Arizona. This discovery was a big deal because scientists were looking for a ninth planet, often referred to as Planet X, that they believed was causing gravitational anomalies in the orbits of Neptune and Uranus. Tombaugh's discovery seemed to fit the bill, and Pluto was quickly accepted as the ninth planet of our solar system. For many years, Pluto was taught in schools as the ninth planet. It orbits far from the Sun, in a region of the solar system called the Kuiper Belt, which is a vast area filled with icy bodies and dwarf planets. Pluto itself is a fascinating world. It has a heart-shaped glacier, mountains made of water ice, and even blue skies and red snow. It has 5 known moons, with Charon being the largest and nearly half the size of Pluto itself. The New Horizons mission in 2015 gave us stunning images and new data about Pluto, revealing its complex and varied terrain. But despite all these interesting features, Pluto's status as a planet began to be questioned in the late 20th and early 21st centuries. The debate over Pluto's planetary status reached a peak in 2006 when the International Astronomical Union, IAU, made a decision that would change how we think about our solar system. The IAU introduced a new definition of what constitutes a planet. According to this definition, for an object to be considered a planet, it must meet 3 criteria. It must orbit the Sun, it must be spherical in shape due to its own gravity, and it must have cleared the neighborhood around its orbit. Now let's break down these criteria and see how they apply to Pluto. First, Pluto does orbit the Sun, so it meets the first criterion. Second, Pluto is spherical, so it also meets the second criterion. The third criterion, however, is where Pluto falls short. Clearing the neighborhood means that the planet has to be gravitationally dominant in its orbit, and there shouldn't be other objects of comparable size other than its moons in its orbital path. Pluto shares its orbit with other objects in the Kuiper Belt, and thus, it hasn't cleared its orbital neighborhood. Because Pluto doesn't meet this third criterion, the IAU reclassified it as a dwarf planet in 2006. This decision was controversial and sparked a lot of debate both within the scientific community and among the general public. Many people felt a sentimental attachment to Pluto and were upset that it was no longer considered a full-fledged planet. The decision led to a lot of discussions and even campaigns to re-planet Pluto. But as of now, it remains classified as a dwarf planet. So, what exactly is the Kuiper Belt, and why is it important in the context of Pluto's reclassification? The Kuiper Belt is a region of the solar system beyond the orbit of Neptune, populated with many small icy bodies. It's similar to the asteroid belt, but much larger and more massive. The existence of the Kuiper Belt was hypothesized long before it was directly observed, and it wasn't until the 1990s that we began to discover these distant objects. The discovery of other Kuiper Belt objects, KBOs, that were similar in size to Pluto, such as Eris, really brought the issue of Pluto's classification to the forefront. Eris, discovered in 2005, is actually slightly more massive than Pluto. Its discovery was a major factor that led the IAU to reconsider the definition of a planet. If Pluto were to remain a planet, then Eris and potentially many other similar-sized objects in the Kuiper Belt would also have to be classified as planets. This would significantly increase the number of planets in our solar system, leading to a need for a clear definition of what constitutes a planet. The reclassification of Pluto to a dwarf planet also reflects the evolving nature of our understanding of the solar system. As our technology and observational techniques improve, we are able to discover and study more distant and smaller objects. This has led to a more nuanced understanding of the diversity of objects that exist in our solar system. Dwarf planets like Pluto, Eris, Haumea, Makemake, and others represent a new category of objects that are distinct from the 8 classical planets. Pluto's reclassification has also spurred interest in exploring these distant regions of our solar system. The New Horizons mission, which flew by Pluto in 2015, provided unprecedented detail about this distant world. It showed us that Pluto is an active and dynamic world with a variety of geological features, including mountains, valleys, plains, and even possible cryovolcanoes. These findings have made Pluto and the Kuiper Belt objects a focus of scientific study, helping us learn more about the early history of the solar system and the processes that shaped it. Another interesting aspect of Pluto is its atmosphere. Pluto has a thin atmosphere composed mostly of nitrogen, with traces of methane and carbon monoxide. This atmosphere undergoes seasonal changes as Pluto moves along its elliptical orbit around the Sun. When Pluto is closer to the Sun, its surface ices sublimate, turning directly from solid to gas, and the atmosphere expands. When it moves farther from the Sun, the atmosphere can freeze and collapse back onto the surface. These seasonal changes provide valuable information about the behavior of ices and the dynamics of thin atmospheres on small icy bodies. Pluto's moon. Charon is also a fascinating object in its own right. It is so large relative to Pluto that they are sometimes considered a double dwarf planet system. Charon has a diameter of about 1,200 kilometers, roughly half that of Pluto, and it orbits Pluto at a distance of just under 20,000 kilometers. The mutual gravitational interaction between Pluto and Charon causes them to always show the same face to each other, a phenomenon known as tidal locking. This close relationship has led to interesting geological interactions and features on both bodies. Charon's surface is dominated by water ice, and it has a diverse range of geological features, including canyons, ridges, and plains. One of the most striking features on Charon is a large chasm called Serenity Chasma, which is longer and deeper than the Grand Canyon on Earth. The presence of such features suggests a history of geological activity, possibly driven by internal heating and cryovolcanism. The exploration of Charon provides valuable insights into the geological processes that occur on icy moons and dwarf planets. The story of Pluto and its reclassification also highlights the importance of scientific definitions and the need for clear criteria in classifying objects. The IAU's decision to redefine what constitutes a planet was driven by the need for consistency and clarity in the face of new discoveries. While the decision was controversial, it has led to a better understanding of the diverse range of objects that exist in our solar system and has helped to clarify the characteristics that define different categories of celestial bodies. Moreover, the debate over Pluto's status has brought attention to the broader field of planetary science and has sparked public interest in the exploration of our solar system. The discussions and debates have engaged people of all ages and backgrounds, highlighting the dynamic and ever-evolving nature of scientific knowledge. This engagement is important because it fosters a greater appreciation for the scientific process and the importance of continual exploration and discovery. The exploration of Pluto and the Kuiper Belt continues to be a priority for scientists. Missions like New Horizons have paved the way for future exploration, and there are ongoing discussions about potential follow-up missions to further study Pluto and other distant objects. These missions aim to build on the data collected by New Horizons and to explore new areas of the Kuiper Belt, providing a more comprehensive understanding of these remote regions. In addition to space missions, advances in ground-based telescopes and observational techniques are also enhancing our ability to study distant objects in the solar system. The use of adaptive optics, for example, allows astronomers to obtain clearer and more detailed images of distant objects by compensating for the blurring effects of Earth's atmosphere. These technological advancements are opening up new possibilities for the study of Pluto and other Kuiper Belt objects. The story of Pluto also reminds us that science is a dynamic and evolving field. Our understanding of the universe is constantly being refined and updated as new discoveries are made and new technologies are developed. The reclassification of Pluto is a reflection of this ongoing process of scientific inquiry and discovery. It shows that science is not static but is always progressing, driven by the quest for knowledge and understanding. Pluto's reclassification has also led to the recognition of a new class of objects known as dwarf planets. In addition to Pluto, other objects like Eris, Haumea, and Makemake have been classified as dwarf planets. These objects share similar characteristics with Pluto, such as being spherical in shape and orbiting the Sun, but they have not cleared their orbital neighborhoods. The study of dwarf planets is providing valuable insights into the diversity and complexity of our solar system, and is helping to expand our understanding of the different types of objects that exist beyond the classical planets. One of the exciting aspects of studying dwarf planets is the potential to learn more about the early history of the solar system. Dwarf planets and other Kuiper Belt objects are thought to be remnants from the formation of the solar system, preserving information about the conditions and processes that were present during its early stages. By studying these objects, scientists can gain insights into the processes that led to the formation of planets and the evolution of the solar system over time. The exploration of Pluto and its reclassification has also sparked interest in the broader field of planetary science. It has highlighted the importance of studying a wide range of objects in the solar system, from the largest gas giants to the smallest icy bodies. This holistic approach to planetary science is helping to build a more complete picture of the solar system and the processes that govern its behavior. In conclusion, the story of Pluto and its reclassification is a fascinating tale of discovery, scientific debate, and the evolving nature of our understanding of the universe. From its discovery in 1930 to the controversial decision to reclassify it as a dwarf planet in 2006, Pluto has captured the imagination of people around the world. The ongoing exploration of Pluto and the Kuiper Belt continues to reveal new insights into the dynamic and diverse nature of our solar system. As we look to the future, we can expect continued discoveries and a deeper understanding of the distant reaches of our cosmic neighborhood. Until next time, stay curious and keep questioning.